Hello grade 8s. Today we're going to look at ratios and more specifically how to create and how to simplify a ratio. Now before we get into that part, let's just remind ourselves what ratios are. Ratios are basically where we are comparing the same type of quantity. So for example, let's say I want to pour myself a glass of Oros. Then I look on the instructions and it has something like this, 1 to 4, which means for every 1 part of Oros I add, I need to put in 4 parts of water. So for example, I will then put this amount of Oros at the bottom, which is 1 part of Oros, which means I need to do the same thing with my water. And so I need to have 4 parts the same size as that. So there we've got 1 part, 2 parts, 3 parts, 4 parts. And that would be my water. Okay. So 4 parts to 1 part. We are comparing how much Oros we have to how much water we have. And this could be in parts of a glass, okay? It could also be in milliliters. So I could say, let's say, 100 milliliters of Oros. Then this needs to be 400 milliliters of water. And that's what's nice about a ratio, because there are no units, because we're saying for 1 part of the one object, we need 4 parts of the other, and we can work between different kinds of units. Right, let's look specifically at what our topic is today. Create and simplify ratios. Now, simplifying ratios is really easy if you know how to simplify fractions. So when we simplify a ratio, it's the same as simplifying a fraction. Whoops, there should be an as, same as simplifying a fraction. And so let's jump straight into our examples here. So our instructions for our examples will usually be something like write each ratio in its simplest form, And here we have our first example. 12 to 18 is the way we would read that ratio. Now the first thing we're going to do is look for our highest common factor between our 2 ratio values. And so we're going to see what number can divide into 12 that can divide into 18 without a remainder. Yes, it is 6. And so we now take 6 and we said what number, and we're going to divide each side of our ratio by 6. Now this part we don't want to see unless it helps you to complete your ratio. And 12 divided by 6 is 2, and 18 divided by 6, 18 divided by 6 is not 6, yes, it is 3. And that is our final answer. And so this part you can do in your head. And we can double check that it's simplified. If I look here, what is my highest common factor between 2 and 3? The highest common factor here is 1. And so we know this ratio cannot be simplified any further. Also make sure that these 2 values are not decimals or fractions. They must be whole numbers. Our next example is going to be 45 to 63. So once again, I start with what is my highest common factor. And if you know your times tables, hopefully you will see that 9 is my highest common factor. And so I will divide both of those by 9. And so that will be 5 to 7. But let's say you didn't see 9, and let's come over here. Let's say instead you saw 3. You thought, oh, let me divide by 3, because you didn't see your highest common factor. So I divide both sides by 3, and if you're not that great with your arithmetic, then you can get out your calculator. 45 divided by 3, so 4 divided by 3 is 1, carry 1, 15 divided by 3 is 5, and then 6 divided by 3 is 2, 3 divided by self is 1. Now if I look at this ratio over here, our final ratio should have a highest common factor of 1. But if I look at 15 and 21, I'm like, oh, there's another factor. I can divide 15 by 3 and I can divide 21 by 3. And so 15 divided by 3 is 5, 21 divided by 3 is 7, and notice we get exactly the same answer. So finding the highest common factor is the best method because it gets us straight to our final answer. But sometimes we don't see the highest common factor, and that's not wrong. You just might need to double check that you have gotten to the simplest form. If we look at 5 and 7, our highest common factor between 5 and 7 is 1, and so now we know we are finished. The next 2 examples I'm going to do are considered complex problems. So if you're trying to get 70 or above, these questions would be good to be able to do. Otherwise, you can listen and see if you can understand, and then carry on with examples B. So number 3, we have got 1/4 to 2/5. Now, if we think about this, I've got one glass over here that's cut up into 4 spaces, and I've got one part out of those 4. And then I've got another cup over here that is the same size but cut into 5ths, and let's see if I can get that right. Oh, 1, 2, 3, 4, 5. So we're using 2 parts out of that, and we want to compare them. But as you notice, our parts are different sizes. So what we want to do is we want to get our parts the same size. And to do that, we need to get an LCD, a lowest common denominator. So we want to know what number can 4 and 5 both divide into. Yes, it is 20. And so we'll make our denominators 20, and I need to multiply 4 by 5 to get to 20. So I need to do the same to the numerator to keep it at an equivalent fraction. And then 5 times 4 and 2 times 4 gives us 8. And so now we have 2 glasses that are in 8s. Now we have 2 glasses that have 20 parts, and this one uses 5 and this one uses 8. And so now these parts are the same size. And so instead of using our units of 20 parts, we can take that away and just say, if I've got 5 parts of the one, I need 8 parts of the other. And so I've got my simplified ratio out of its fraction form. So let's just go through the steps. You're going to find the LCD. Once you've got the LCD, you don't need the denominator anymore, and you write the numerators as a ratio to each other. And then lastly, just check to make sure that your final ratio is simplified. So 5 and 8 do not have any number other than 1 that can divide into them. Example 4 is also complex, 0,14 to 0,7. Here again, we have got a format that we're not allowed in ratios. So we want to turn these decimals into whole numbers. And so remember, when you multiply or divide by 10, you can move your comma up and down. So we want to make this a whole number, so we're going to have to multiply by 10. Let's start with that. So if I multiply that by 10, I'm going to have 1,4 to 7. Now 7 is no longer a decimal, but 1,4 is still a decimal. So I need to multiply that by another 10, and so that's going to give me 14 to 7. So hopefully, while seeing me do that example, you found a little shortcut. So 0,14 to 0,7. When I look at my two ratios, this one only needs to be multiplied by 10 to become a whole number. This one has 2 decimal places, so it needs to be multiplied by 100 to become a whole number. So I'm going to go with the bigger amount so that I can immediately get out of my decimal. So 0,14 times 100 will take me to 14, and 0,7 times 100, so I'm going to also multiply that by 100 to keep my ratio the same, which will give me 70, and you can double check on your calculators. So from there to there, we multiplied both ratios by 100, and that should be 70 over there. And then our final step is to double check. Is there a number that can divide into 14, that can divide into 70? And possibly you see, oh, I can divide by 7. 14 divided by 7 is 2. 70 divided by 7 is 10. And then I double check. Is there a number that can divide into 2 and 10? Yes, they're both even, so we know they can both be divided by 2, leaving me with a ratio of 1 to 5. Here is our final example, where they will ask you to actually create a ratio. So write a simple ratio of hockey balls to rugby balls. And over here we've got our hockey balls. Let's add a few dimples onto them just to make them look a little more like hockey balls. And over here we've got my terrible addition of rugby balls, and let's put a few more in there. I'm not the greatest artist. So very important is to look at the words for what order your ratio needs to be in. So here we have hockey balls to rugby balls. And remember, 2 is how we say that dot dot, which means that when I write my ratio, I need to have hockey balls first because it becomes before the 2. Then I need my little dots, and then I need my rugby balls. That's the most tricky part of this whole problem, is deciding who comes first, and they will always tell you in the words. Next part is easy. Hockey balls, I count 3, 6, 7, 8 balls. Rugby balls, 1, 2, 3, 4, 5, 6 rugby balls. And then don't forget to simplify. So what can go into 8, that can go into 6. Yes, I'm going to divide them both by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. And there's my ratio in its simplest form of rugby balls. So for every 4 hockey balls the hockey team has, the rugby team only has 3. Quickly, before I end off, I want to show you a little trick on your calculator. You can use your calculator to help you check your answers. So for example, we have 12 to 18. I put on my calculator, and as I said before, ratios can be simplified the same way as fractions. So if I put 12 to 18 into my calculator as a fraction, so 12, fraction button, 18, and I push equals, I get the fraction 2 over 3. And so I can double check my answer. 12 was at the top, so 2 should be under 12. 18 was at the bottom, so 3 should be 18. And that is my simplified fraction, 2 to 3. Now I want to come back to this one where we have 0.14 to 0.7. Let's say our ratio went the other way. So let's write it over here. Let's say I gave you this ratio instead, 0.7 to 0.14. And you got a final answer of 5 to 1. And you double check it on your calculator. So you would have 0.7 over 0.14, push equals, and that gives you 5. Now that's not a fraction, but remember 5 is actually 5 over 1 when you write it as a fraction. And so you can see there's my 5 is the first part of my ratio and 1 is the second part of my ratio. Grade 8, don't forget to go and practice this now using the worksheets provided.